Good morning. Hello, my name is Kyle Oba. Thank you to all the organizers and the volunteers for, this has been an amazing experience so far. I'm very excited to be here. As you can probably tell, I'm a little bit nervous. So I'm just going to dive right in. All right, so I work at a company called Pot de Chocolat. We work on local problems with local clients. We try to find local solutions as much as possible. We're a research, design, and development company. My partner and I started this company before moving to Hawaii, but she's actually from Hawaii, so that's where this whole local-centered design and research comes from. We partner with other researchers, designers, and programmers, but enough about me. Oh, I'm sorry, you can't see my slides. Oh no. Should I just try to restart that? Okay. Oh boy. Okay, cool. Thank you, thank you. That's my presentation. Keynote is a thing. It used to work. Okay, so cool. All right, so diving right in. So the unprecedented. So Shoshana Zuboff just recently published a book called The Age of Surveillance Capitalism. I'm not going to pretend to have read the whole thing because it's like over 700 pages, and I'm a busy person. But yeah, so this idea of the unprecedented, and in her own words, the unprecedented is necessarily unrecognizable. Right? So when we encounter something that's unprecedented, we automatically interpret it through the lenses that we're familiar with or of familiar categories, thereby rendering invisible precisely which is unprecedented. When I read this, I was thinking, wow, this is amazing. I originally was going to center this talk all around context, but I really like her idea here. And so if you were living or visiting Hawaii about a year ago exactly almost, you would have received this on your phone. It's all caps, so you know it's important. Ballistic missile threat, inbound to Hawaii, seek immediate shelter. And then if you're like, is that real? It says, this is not a drill, which, usually people are drilling me at 8 in the morning on Saturday, but whatever. Yeah, so from my own experience, I saw this, it was Saturday morning. I was just kind of calmly doing stuff in the kitchen, looking at my phone, and I guess I'm going to die, right? And usually when I see, we're all going to die, but whatever, but when I see this type of message on my phone, and maybe some of you got this last night, but it's like there's a flood coming, maybe, there's a hurricane on its way, maybe you should care, maybe, right? And so that's kind of the lens that I used to interpret this message, which is kind of like what Zuboff is saying, it was totally the wrong lens to use. It was just a lens that was familiar to me. So I immediately started filling my water filter in the kitchen with water, which seems reasonable, but then 38 minutes later when they say, just kidding, that's not real, I really had time to evaluate my own behavior, and it really didn't make any sense. I mean, if we got hit by a missile, I was pouring water, didn't really matter. Okay, cool, so that's the idea of the unprecedented, how we require these lenses in order to interpret new things. And so obviously this talk is a little bit about artificial intelligence, which is kind of this weird broad term. So how is this relevant to us today? So as builders and designers, as a lot of us are, we need to create that new lens for ourselves in order to interpret that which is unprecedented to us and to the community or to society. Yeah, one of the common themes to a lot of the work that we do is that we'd like to try to find the unrelatable, things that are invisible, things that are undefined, and try to make them more relatable, visible, and articulate them more fully. And it's only through the creation of these new lenses that we can then further these discussions with our communities. So as an example of that, I wanted to take you all through a project that we did with the Honolulu Museum of Art, which is just down the street, and I highly recommend it. So about the time that alert came out, we had the opportunity to do this project with the museum, and we called it a design intervention, and we wanted to sort of forward the discussion of surveillance technologies. So at the time, they had this program called Classified that was produced by the Doris Duke Theater, which is in the museum, which was to highlight the screening, highlights of the program were screening of films, including Laura Poitras's Citizen4 documentary about Edward Snowden, and there was also a panel discussion. So the panel discussion took place on just one particular day. It involved Kate Crawford, one of the co-founders of the AI Now Institute, Trevor Paglen, an artist who works with surveillance technologies, Laura Poitras, the director, Edward Snowden actually Skyped in, and Ben Weisner, who's his ACLU attorney. And it was moderated by Hassan Elahi, another artist who works with surveillance technologies, or surveillance in general. And so we were invited to sort of come and create an experience, and so we dubbed it a design intervention to complement what was happening in the panel. So the museum called it the My Profile Tour. I'm not sure how I feel about that name, but that it stuck, so that's what it is. It's the My Profile Tour. It's a little 2000 for a name, I think, a little bit, but it's cool. So the purpose of our design intervention was to sort of raise awareness about things that can go wrong. So the fallibility of face detection, face recognition technology, and problematic data privacy issues. So this is like about a year ago. So we weren't, well, I'll just leave it at that. So we weren't totally sure what was going to happen with those issues, but we knew they were problematic. Anyway, so this was meant to introduce the public to specific technologies and the use cases of machine learning and this giant amorphous AI thing, and to replace sort of those marketing buzzwords with a little bit more articulate discussion and specific discussion about these issues. All right, so what did we build? So we built so this is, I don't know, elevator pitch. So we built individualized tours based on guests' faces matched to art currently on display in the museum. Okay, and I know a lot of you are thinking, isn't that what Google did in their app for Google Arts and Culture? And now, I'm not lying when I tell you this, and that's what liars say, but anyway, they released their app like 2 weeks before we went live, and it was just sort of uncanny. I actually didn't find out about their app until after the panel, and I was like, oh wow, that's disappointing. But at the same time, it was really interesting because they were doing something very, very similar. So I'm going to kind of walk you through how we did it and some of the differences. But I think it was an uncanny coincidence, and I think a lot of it had to do with how good certain types of technology, or like face recognition and detection, were getting at about that time, and how easy it was to apply. So, all right, so cool, the My Profile Tour, how did it work? So step one, you had to opt in. Not everybody had to do this. As you can imagine, at a panel discussion where Edward Snowden is Skyping in the state of Hawaii, where he used to work, it's a little bit weird to have somebody ask you to take a picture of you before you go into the panel. So you had to opt in. And then if you did opt in, we took a picture of you. And it said, hey, this is the picture we're taking. Would you like to opt in? If you did, we kind of labeled you in the real world. We gave you a sticker. It had a number on there. It's sort of a symbolic, like, this is happening to you. Yeah. Well, I mean, let's be fair. Not every website does this. Okay, well, they don't give you a sticker. Well, actually, the stickers are a thing, but anyway, okay. Oh, yeah, incidentally, ask me later. I have stickers to give out. All right, cool. So the fourth step, customized tour. So the panel was an hour long. So before you walked in, we took your picture. When you walked out, we handed you a customized tour. So there was a lot that went into sort of printing and formatting and laying these things out ahead of time, so that only the live customized content would be applied. Cool. So the process. So I know this is a little small for you to see. I'm sorry about that. This is sort of like a version of what we put out in a handout. And so basically the top part of it is stuff that happened ahead of time, and the bottom part is stuff that happened on site that day. And I'll walk you through that. So step one of, I think, almost every one of these machine learning / whatever you want to call it, artificial intelligence projects is data collection, right? Or getting data from somewhere. And so as you can imagine, when you're working with a museum who hasn't really done this type of thing before, data collection is hard. Data collection is hard, in my experience, no matter what project I'm working on. So we had to walk through the entire museum, find out where all the art was, write down all the numbers associated with that art, and figure out what they were called, what room they were in, and then get a photo of everything. That was a lot of work. And then we sort of processed the images of the art as well as the sculpture, so anything that they had that was going to be on this display at that time, that wasn't in sort of like a special exhibition where we weren't allowed to photograph the art, we pass it through a face detection neural network, which essentially just says, hey, I think there's a face here, and I think it's inside of this rectangle. And then you can highlight that. Or crop it out. So in this case, we just cropped out the faces, and then we used a second neural network, which was a landmark prediction neural network, which essentially says, hey, I think the eyebrows are probably, based on you telling me this is a face, I think this is where the eyebrows are, the eyes, the nose, the mouth, the jaw, et cetera. And the image on the bottom there, which is me, I just wanted to throw in here that although we did a lot of this in Python, because the beginning of every web project using machine learning is to install Python on your machine. This is something that you can actually do in the web, so I wanted to put this link here. This is an example that runs in ML5.js and is rendered with P5.js, or sort of like put into the browser with P5.js. It's super cool. So if you're like if you love JavaScript, you can do all of this stuff from the comfort of your JavaScript. But just remember, you have to install Python because that's just required. But don't be afraid of Python. It's just executable pseudocode. All right. Next. Let's see. That's a joke for the Python people. All right. So this prepares us for numerical comparison. So we can actually pass that set of landmarks through a face recognition neural network, but then essentially render that image into a bunch of numbers, right? Like big vector, right? And so now that we have sort of a face and we know where the landmarks are, we've turned it into a bunch of numbers, we can start matching it to things. Okay, so like so we save all that stuff away, and then on the day of the event, people come in, we take their picture, right? And then we find the landmarks on their face, and then we can render them into numbers and then match them to the art that they're similar to. Cool. And then since we have scary facial recognition software, we can then say, hey, do you want your tour? Oh, we know who you are, so here's your tour, right? So that was another thing we added. So it wasn't just about matching faces to art. We also did a number of other things. So this is the tour folded up that we handed to them. So it has their face, it has their landmarks, and it has a number of super problematic classifications that we said were attributes of you based on your face. And this was not meant to be like true, it was meant to be like super problematic and something that people should question. So special thanks to Kyle McDonald, who's an artist who trained the neural network to work with these classifications on the labeled faces in the wild data set. It's another one of those things where you can pop that thing into, well, anyway, I won't go into it. So these labels were super problematic, and I think in some cases kind of insulting. It might tell you you're not attractive, right? And some, it might tell you you look tired, stuff like that. And that's not something you want to hear from a computer or anybody, but nonetheless, computers will do that. And so the next page, this is the stuff that was, besides the labels, was custom generated. So here we're able to say, okay, we think you look like this painting, we think you look like this sculpture, and then based on everything that was in the frame when you took your photo, we're matching you using a different neural network that does object matching. And I'll go into that in a little bit later. And then, because of your classification that we gave you, we're going to say this piece of art is something you might be interested in based on what was strongest in your classifications. And then we created a path through other pieces of art that sort of like provided this sort of like trail that you could follow from one piece of art to the next. This was an educational project, so what we really wanted to do was to provide people a way to question the technology and have it be personal so that people could have a more articulate discussion in the community. So we also wanted to highlight where our technologies failed. I'll go into that in a little bit. And then also we provided details about how the artwork was chosen, at a very technical level, if people wanted to dig in that as well. So cool. So one of the things that we really wanted to do was to say, what are the ways that we can use to find art that we can match to people? And so one of the techniques that we came across was something called reverse image search. And so reverse image search, essentially, you take an image, you use an object detection neural network, and you kind of short circuit it to provide you with numbers instead of names of things. And then with those numbers, you can sort of compare them to other objects and find in the data set other objects that look the same. So I'll just kind of let that picture explain itself. One of the neural networks that you used was called VGG16. It's 16 layers. You slice off the last layer that basically tells you what the thing is, and you're left with a giant vector for every object that's numbers. Here's another example of finding stuff that's similar to the base on the left. So once you've got these numbers, you basically have coordinates in this multi-dimensional space. And you can use traditional distance algorithms to see what's close to what. And then once you do something called PCA analysis, or principal component analysis, you can slam 4,000 dimensions down into 2 dimensions using this algorithm, which essentially maintains closeness of points in multi-dimensional space in the 2-dimensional translation. And then once you're in 2 dimensions, you can use your traditional graphing algorithm or graph algorithms to find shortest paths like you would to find a route through a city. So in this case, we have a picture of a person, you may have heard of him, and a vase on the right-hand side, and we tried to find items in the museum collection that would sort of like transition from one to the next. I'm not sure how convincing this is. I kind of think it's convincing. Maybe it's like bias on me for selecting this, but anyway. You kind of get the picture. This is how we selected the art. So lessons learned. We had to try a lot of different ways to try to find things that would work to convincingly match you to something that's in the art, right, to a piece of art. And once we got to this point, we're like, yeah, that's pretty good. Zuckerberg looks like that guy, so okay. We're like, we're done. All right. But there's also mistakes that are made, and I should have put like a warning or something on the previous slide. So we started out with this thing called the OpenCV HAR classifier to find faces, and it turns out it's not that good, or at least it was good for a while. But then when these convolutional neural networks came out, we ended up using one by it's called dlib, which has a Python API. It got much better, but we were getting results like this, and I mean, it's like automatic screenshot save, right? All right. Also, privacy policy. This is one of the lesser successful parts of the project, was we put a giant wall-size terms and conditions on the wall to remind people that we were taking their images and making conclusions about them and recording it on a computer and basically saying all the horrible things we could do with that information. And then at the very end, we say like, but we're not going to do it, and we're going to delete your data in 30 days, but you should really think about this. And I don't know what it is about putting terms and conditions in front of people, but they don't want to read them. So almost nobody read this, which is a little disappointing for our graphic designer that we work with. But it did teach us a lesson that it was really incumbent on us to make this more approachable and consumable. Another super difficult thing to deal with was using the classifications and labeling the data that exists in the wild, or exist currently, right? If you look at this, it's probably too small for you to see, but if you look at this up close, you'll see that there's only 4 ethnicities available in the labeled faces in the wild attribute classifiers. Black, white, Asian, and Indian. I thought Asians and Indians were kind of, but whatever. And we're in Hawaii. We're doing this project in Hawaii. There's a lot of Southeast Asians, right? If you just say Asian, you're like, I don't know. And there's it's everybody almost. And yeah, and there's no Hawaiian, right? So so you're kind of like leaving out a giant portion of the population. And then also, I probably don't need to go into it, but art collections that you're using this for also have a bias. Kind of taking a wider view, I found this when we were doing our research. There's obvious bias here. I don't need to go into it, but the data set has a bias. The engineers have a bias. There's bias out there, people. Anyway, and then, so this is Hawaii. Hawaii is weird, and this is why it's my concern. Hawaii is super unique in the United States. We're #1 in terms of the percentage of non-white population. Even looking at this chart, there's no category for Hawaiians. There's also no category for mixed race or ethnicity. So why is that, right? Because the bar graph tool didn't really allow for that. And then also, locally, our police department just bought 1,200 Axon body cameras, which sounds a lot like, well, anyway, Axon body cameras. And I'm a little worried about that because, Axon has an AI division headquartered in Scottsdale, Arizona. And, if bias is a thing, maybe this is something we should be concerned about. Hawaii looks very different than Scottsdale, Arizona. And a worthwhile, so I think in the words of, so I'm going to leave you with a couple of quotes. So a worthwhile exercise would be to delete the word technology from vocabulary in order to see how quickly capitalism's objectives are exposed. Okay. Marketing is powerful, right? AI, I believe, is one of those terms which, if not more clearly defined, is essentially just marketing, right? And AI means anything that's all-powerful and inevitable. And as long as we allow that term to be just thrown around without properly defining it, we're basically giving in to this sort of desire to just say, oh, it's inevitable, it's all-powerful, it's going to happen, let's just let it, right? So there's an opportunity for us, and I'm going to just kind of go through this real quick. But this is actually happening. Like, people are getting tickets in China because their picture goes across the intersection, right? We don't really have to let that happen, but we do. This quote by Evgeny Morozov. So inefficiency is precisely what shelters us from the inhumanity of Taylorism and market fundamentalism. So when inefficiency is the result of the deliberative commitment by a democratically run community, there is no need to eliminate it, even if the latest technologies can accomplish that in no time. I love this guy's books. I highly recommend them. Essentially, sometimes inefficiency is a good thing. We should think about it when we eliminate it. And then finally, so technology is not and never can be a thing in itself, isolated from economies and economics and society. This means that technological inevitability does not exist. And I love this quote. It's everything that we love about the work that we do. It's learning about the communities and learning about the technology that they use and understanding when it's appropriate to apply the technology and when it's appropriate to step back and just sort of listen. So I encourage you all to take this, I wanted to end on a high note. So to take what I've said and sort of go forth to your local communities and see how you can create your own lens and use your lens to shape the future with these technologies, because none of this is inevitable. All right. So thank you very much.